Hello everyone, welcome to CEDA Lighthouse Project Season 2, the power of graph convolutional networks, master graph-based machine learning. So myself, Roopesh Bharatwaj K R here.
So we had attended our last section of introduction to graph data and graph neural networks. Today we're gonna start regarding our graph building strategies. So this is our second phase where we'll be gonna delve into hands-on session as well, and we're gonna start with our Neo4j as well. So we are in our second class of graph building strategies here. So out of 10 weeks class, we are in a second class right now, and this is a very important class. So in this lecture, we're going to discuss about the basic graph visualization tools, how the Neo4j queries are being used, and how to create a node edge, how to create node properties, and we're going to talk about a graph data science library as well, and we're going to do a small demo session as well. So last week we discussed a basic overview, what are the graph visualization tools there. So there are some leading tools and libraries here, like Neo4j Bloom, that's part of Neo4j, and Network6 library is a Python library, and Gilpy is a tool as well, and iGraph, D3JS, PyTorch Geometry, Cytoscape, and Deep Graph libraries. These are like couple of Pythonic tools which we have. So let's start the difference between what's a native and a non-native graph DBMS. So we are all aware of two different graph structures. They are like graph-based structures, and like another one is like a relation database or database structures. So popular graph-based data structures are like Neo4j, Azure Cosmos DBs, Amazon Neptune, and ArangoDB. Same like database management, environments like MongoDB is there, Cloud Firestore is there, and like RDBMS, Cassandra is there, MySQL is there. So these are all our basic differences between our database management system. So what is the difference between a native and non-native graph DBMS? In a native graph, so it is like a very highly efficient for traversing the complex interconnection data, and it performs well in a very large connected data sets where from millions of connections of nodes or multi-billion connections of nodes, it's possible. In non-native one, it's kind of like a very slow in performance when there is like a more connection of networks. So it reduces the complexity, and it has like a huge cost in like traversing the data, and almost traversing is also not possible with certain RDBMS. So in graph database, there's a custom built persistence layer which can handle the graph data structures. Unlike in non-relational database, where like Cassandra and MySQL, they rely on like a persistence layer. So without a persistence layer in the graph, they can't traverse from one point to another point. The native graph, which is well suited for handling like large scale of data, and non-native, as I said earlier, they will be useful, but they will be kind of like struggling to, to traverse from one point to another point when there's like a very huge connected data, so from millions connections like Twitters and trends. So native graph ML, like they are very suitable for pattern matching, and non-native on RDBMS, they are like very less efficient for graph database operations. The native graph DBMS are like useful in case of fraud detection, recommendation system, biological management system, recommender engines, and supply chain management. So in non-native one, they can be used, but the latency level is very low, and it requires like a smaller amount of data sets to connect them. So in basically in our graph databases, we have like a future proof. We can extend those data to n number of nodes, but in native one, we can't extend it, and it requires like a lot of complexity and computation cost as well. That's the difference between like a normal graph and like a relation database. So moreover, in a graph, it requires like extended like specific set of like knowledges, and we need to have the skilled and trained deployment activities there. But in non-native development, we, with the help of like a non-persistence layer, it is easy possible for us to deploy our databases. So let's start with like difference between RDBMS and Neo4j. So let's take one example for RDBMS and let's try to solve how RDBMS is useful. So here is a table of we have the primary key as ID 123, and we have a group name as top group, some group, and other group, and all parent ID has a foreign key related respect to it is 1, 1, and 2. So what is the task here is like what is the parent ID of the group with ID of 3 in the group table. So we need to find what is the parent ID of group with this table as a primary key, as a 3 as the main. So now let's see how our SQL can be used in this. So basically, in our SQL point of way, so we'll be coming from like a down to top approach, bottom to top approach. So we have selected our table here, and we have selected from our groups, and then we have finded our different what's the parent ID is there, and then a nested query is again put it in inside where which finds the exact number of IDs there, and finally we kept the ID, the primary key of 3. Now this primary key of 3 will fetch this like it goes to like a second nested loop of 2, and further than the second nested loop of 2 goes to the first one, and finally it fetches the result as 1. So this is our we got like result as 1, but here the important thing is like how these results are being calculated. So as I said earlier, it requires a lot of like computation cost here, and it is like a nested in queries is here. It starts from like innermost clause, and then it falls into like subclauses, and then again it moves to subclauses, and finally it repeats these steps back to back. Once these steps are being done, that's how we got the result as 1. So we got result as 1, what and all causes and what and all like has happened. So we did like 3 different types of planning cycles we did like, and we did like 3 index lookup we did, and 3 read operations we had done. So why? Because we read like 3 different times because of the 3 nested loops we have. So basically, because of these, the resulting like 3 planning cycles, 3 index lookup, and 3 database operation cycles, our time complexity is moved to O of log n. That's logarithmic time. So basically, in this time, like we it requires a lot of it takes like too much of time to process each and every like read operations, and it completely it is much more expensive in terms of deployment, or it causes a lot of lag in processing each and everything. So how can we overcome the same stuff with our Neo4j? So let's have the table. So now we know like we have shown like different tables we have, the top group, the other group, and some other group. The top group is connected with like a like child of 6, and some group is connected with the child of 5, and again top group 1 is connected with the child group of 4 and reconnected again. So basically the Neo4j uses index free adjacency, which stores the nodes and relationships and the objects that are linked via pointers. So now we can see our target. We can see a different points of connections, right from like a node of 3. So node of 3 is directly connected to 6, and node of 2 is directly connected to 5. Likewise, I have just added an extra node, a 6 as well, and node 1 is directly connected to 4, and here I have added extra as well for 5. So this is a graph which I have created here, and let's see how these graphs are like interconnected with each other. In our SQL, we did like a lot of nested queries in order to get the answer as 1. But unlike in a Cypher queries, we don't need to do like a nested queries at all. So we're gonna do it based on the name of that group and the ID which we want to achieve that. So we we want to get the achieve the ID of a parent. So which is in a 3. And let's see how is being computed and how fast is our Neo4j. So basically, as I said earlier, we want to calculate the which parent group of ID3. So first parent group of ID3 is directly connected to a link of 6. So we, in the sense like now the graph data here will go directly look into the child of 6, ID of 6. When ID of 6, we're gonna check the connected links here. So they are like 3 and 2. So 3 is already visited, which we had, and now we need to move into 2. In in node of 2, we already have a link of 5 and 6. So first it moves to 5 to check. And 5, it's already 2 is already visited, and again it reaches to 1. And next one, the once it reaches to 4, reaches to 1, it links to 4 and 5 here. And rebacks to the link node of 1. And that's how we got the node as final result as node as 1. So like this, we will be pointing from one point to another direction in a straight away. Instead of doing like 3 times or 4 times of our read and write operations, we're going to do everything in a single operations. The single operation will result in fewer index lookup and no table scans, and it completely reduces the duplication of data. And moreover, the time complexity is O of 1. That's like constant time. So most of the databases are in lies in this category. And the whichever has like a O of time or like a one, it's like a constant time. That means like it has like a very high lightning amount of speed in like reading operations and writing operations. So that's the important strategy of like our database, which we need to look into deep once we gonna deploy and do all of our processes. This is the basic example of what is our relation database and what's a graph structure database. So in our relations database, we are in a like a multiple read and write operations is there. So it naturally falls under like logarithmic time. And in a graph database in our Neo4j, why? Because we use like a index free, and it falls into like overphone, like it's constant time complexity. So which is much better in terms of deployment and like large scale, like a complexity querying and like large management of data with millions and millions of nodes and edges, it easily able to connect from one node to another node within a no matter of time. Like instantly we can read them. That's the benefit of Neo4j. So let's go deep into like what is the root cause of this and how it is being achieved here. So basically here it is achieved using the index-free adjacency. So index-free adjacency, it is a mechanism which stores the entire data in nodes and relationship format once we start with the graph operation itself. So once it's already stored, now the process to read automatically in those like pointed directions. The node is pointed directly to another node, and those relationships are already being mapped. So it's become very much faster and easy for our Neo4j storage to read it and process it in no matter of time at all. So that's the biggest benefit here for like a Neo4j we have. So let's go into deep about Neo4j and what are all those terminologies has been used. So as we know earlier, like Neo4j is like a graph database, and it is like one of the a leading database in the market right now, and it has like own Cypher query languages it has uses, and it has like no, Neo4j Aura DB. It's nothing but like a cloud based data storage for like a Cypher querying and processing everything, and it has its own built-in graph data science library. So graph data science library is like a powerful library which has like a end to end, right from like our training of our machine learning and like built-in pipelines of data, built-in pipelines of like machine learning libraries until the production and deployment, which it has. So next important thing is like Neo4j Bloom. So Neo4j Bloom, it is a visualization tool which is used by the Neo4j to read the data and to visualize visually what is and how it is connected, and how can we increase the nodes and edges and those connected relationships. It can be easily viewed in a Neo4j visualization tool called Bloom. And finally, and there's like the good concept here is like we can connect this our entire Neo4j with our Python library, and we can connect it like a Neo4j with like .js, and we can connect with like Java as well. There's like a lot of built-in pipelines, and like based on the respective languages, we can use and consume the Neo4j using the drivers and APIs. And we can also consume the graph data science library with different languages like Python or like Java or .NET and anything using APIs and like built-in pipeline calls. So let's start get more about like a cyber query language. So let's start with like a Cypher query. So basically, the Neo4j Cypher query language, it lets you to retrieve data from a graph. It's similar to graph like SQL query language, and basically it is inspired from SQL only. So we all know like a relation database or like normal database requires a SQL as a structured query language to understand and retrieve and like update our data. Similarly, in a Neo4j, we have like a Cypher query language. It is written on ciphers, basically, and it's inspired using SQL. So now let's go deep and of creation of and node properties. Here is our hero Aaron and our heroine Mary. So here Aaron is like age of 30 and Mary is age of 27. So how can we create a node with a name as as a label as a person, and the properties, the name as Aaron and age is 30? And similarly, how can we create the person Mary with a label and their properties and their age? This is the basic syntax of creation of our node along with its properties. Likewise, how can we create our edge? So Aaron is married to Mary. So now wife is our relationship here. So that's the important concept of edge. So how can we define from one node to another node with the help of a relationship that's called edge? And here Aaron is married to wife, and wife is a relationship here. So we can define our relationship like the person one is directly connected to person two in relationship form as wife. Also, we can have age properties. Here, the wife is one of the relationship, and we need to ask like when did they marry? So we can we have written as like since 2015, Aaron married to Mary. Here we have kept like wife from since 2015. Likewise, we can add like many number of their properties, like their places and much more. That's how this is the basic building blocks of a node and edge. We think about a network like multi-million users like Facebook and everything, and see Aaron is just a single node in it, and Mary is also another node in it. Likewise, how they will be connected with multiple nodes and edges of a Facebook if they were in Facebook. So let's start with another implementations of like Aaron and Mary love story using a Neo4j demo. Thank you very much. So basically, this is a Neo4j desktop. So once you have been using here, so next important step is to add a new local DBMS. Just create it with your own name and your password. Once you click create, your database will be automatically created, and then you can open that same database. So we had opened a database, and now let's start with creation of a Aaron and Mary love story. So Aaron is age 30. So he is from London and his sex is male. And he got married to Mary in 2017, and she is from Dublin and her sex is female. So let's start with creation of small nodes. So let us create person one, person. His name is Aaron. His age is 30. City is London. We have created our node. Let's check the node and see. So match and return in. What it shows is like match all nodes and return all nodes. So yes. So now we have Aaron here. His age is 30, his city is London, and his sex is male. Likewise, let's create a node for Mary. Two. Her age is 27. Sex is female. Her city is Dublin. Yes. So now let's see, check the nodes. Yes, we have created nodes, Mary and Aaron. So let's connect both Mary and Alan. Let them marry now. Yeah. Person one, we're gonna give the relationship as wife, and we're gonna give a node property as well. So when did they married from? Since 2017. With whom is the question? That should be Mary. Person two. Yes. Now let's check match and return. Yeah. Yep. So the problem what we are doing right now is generally these all queries should be in a single, like a single page. So we had made like duplications here. That's the reason why the person got connected like this, like without a name and everything. So in order to do that, we need to first delete everything again. Match and detach, delete, and so which deleted all the existing nodes. So let's take let's copy this as well. Let's visualize now. Yes. Now we have the relationship as wife. When did I married? Since 2017. So this is a basic example. And now what we can do is we can extend this. So we will create like another couple more persons, and let's make like how interactive it can be, and then later on we can query on this database and retrieve the informations. So now what we can do is like let me create another node called Facebook. Social media. Name of the social media is, oh sorry, name of the social media, and now it's like a property here. Name is Facebook. When was created? 2010. Owner. Right. And again, let's create another node as well, and let's connect when the Aaron and Mary joined Facebook. Person one joined Facebook. Since 2000, well, and connected with Facebook. There is a mistake here. So let's join this entire queries, There should be some duplications here. Yeah. Let's delete the node right now, and then we can create. Now let's view it. Match in, return in. So now we have created a new node called Facebook, and we have connected Aaron when he joined. He has joined since 2012. So likewise, let's create like multiple nodes and visualize how it's happening. Since I have already created this, let me do like a paste right now. So here I have created a person named Aaron, and his like node properties or city, London, sex. And similarly, the person two is another node. His properties are Mary, Person 3, his name is Julie, and person 4 is Stella. So here, what is the story is like Aaron joined Facebook in 2012, and at the same time he started to date another girl as well. So she is a Julie, and another person again he started to date, and that's Stella. So these were the different set of nodes were happening here, and we have connected with them, and let's visualize that. Let's take the Facebook here, and Mary, Stella. So here's a beautiful love story here. Now Aaron joined Facebook in 2012. At the same time, he started to date Julie in 2012, and Julie joined Facebook in 2010. So their love story was like going very well. At the same time, Aaron was like too much into like a low mood. He started to love again Stella in on February 2013 on Valentine's Day. So surprisingly, Julie came to know that uh, Aaron dated Julie and Stella since Julie and Stella are friends, and they came to know and they breaked up Aaron. And finally, Aaron, what he did in 2017, 2015, he started to make a Facebook friend of with Mary, and they were mutually very friends, very friends. And later on in 2017, Aaron married Mary, and Aaron gifted a Mary a car. That's for like a Ferrari car of 4 million as a surprise gift to Mary. And later on, he cooked Aaron Mary's favorite food, biryani. That's the like network here. And now what we can do is like we can do like a set of queries here. So how can we retrieve this information from our database? Let's see how many friends did Aaron had. Match. Here is our relationship friend. Friend.
Can I ask a question?
Yeah.
Say you've got match person 1 colon perso. Why does it say perso?
Can you state me where it is? Sorry.
Oh, it's gone now. It's the last command you typed.
From this query?
No. There. In
Yeah.
the error message. So it says match bracket person 1 colon
Yeah.
perso. Why does it say perso?
Why? Because that is the label which we had.
Okay.
So we are
It was
referring.
type on some point, maybe.
Yeah. See here this is the node called person, and that specific node we are referring it as person 1. And the person one properties is Aaron, its name, age, city, and sex. That's how we are creating a node.
Yeah. So you create a node called person1 of object type
Exactly, yeah,
person.
exactly. See here,
But
yeah.
then why do you later
Person,
refer to it as perso without the n?
yeah. So this node called name is person, and his properties are age, city, name, and sex.
Yeah,
Yeah.
but the question is that probably we guess you missed the end at the end in the last
Is it
query.
just a sorry, is it just a typo? Because I see you've done it several times. Like PERSO,
Yeah.
not PERSON. Is that just a typo or is it some kind of alias?
Yeah, it's a typo. Yeah, basically. Yeah.
Okay, that's fine. So it's not case sensitive either, is it?
Yeah. It should be just.
I'm sorry, Roopesh.
Yeah,
Can I ask another question?
definitely. Yeah.
I'm trying to do the same as much as I can while you're showing us, and I'm wondering where you get the visualizations from. How do you visualize the graph?
Yeah. So I have used a query called match and return in. So here there's like a lot of tables here. This is the graph option here. This is like a table option, and it's the textual option, and that's the code which we're gonna have. So you need to click on the graph option.
Yeah, I don't have it with me. Probably just some a matter of.
Yeah,
Let
can
me.
you share the screen? Yeah.
Yeah, let me try it out first, and if it persists, I'll try to
Yeah,
query it.
that's
If
fine.
it
Yeah,
persists, I will ask again. Thanks.
that is fine. Yeah, let me get back to the Neo4j. I'm just restarting Neo4j. Yeah. So in meantime, so we have created our love story of like Aaron on Mary, and we have connected like a different nodes and edges with their relationships. Like we have built a big graph. Now let's check what's a graph data science library. So graph data science library, it's one of like a popular tool of Neo4j. So which contains a lot of information regarding the plugins, the ML solutions, the ecosystem, the entire production pipelines from end to end, the entire the production pipelines from like the data streaming platform till to the deployment services has been managed using a graph data science library. In graph data science, as I said earlier, there's like a end-to-end, right? From feature engineering, data exploration, the graph querying, graph visualization, Bloom, graph data analytics, graph algorithm, graph machine learning, and graph neural networks. We can build a multiple different levels of projects using this, and it's like for deployment services as well. So graph algorithms, they are like a standalone graph algorithms are being used here, are inbuilt pipeline like function calling algorithms also have been used for graph neural networks here, and graph embeddings is also used for like a powerful recommendation system building, and it has a support for natural language processing as well, and building the entire end-to-end recommender system and knowledge graph. So Neo4j RRDB. So Neo4j RRDB is none other than a entire cloud services of Neo4j. So since we use a Neo4j desktop version here, so the same, it's completely free. That's in RRDB, where they have like a specific points I want to mention you. Because the Neo4j and the graph is like completely like a booming right now, and Neo4j team is also in like in development as well. So I will suggest you to use graph desktop, Neo4j graph desktop for our entire implementation part. Why? Because the Neo4j desktop alone supports graph data like science library. And Neo4j RDB, they don't support the graph data science library on a free tier version, but they do support on a professional version. So which costs like around like 60 to 70 euros per month. So I would advise you, we can stick on with like graph, like desktop version of Neo4j. And we'll be using a graph like RDB as well. for specific set of challenges and tasks, right? For like conversion of tabular data into graph structured data. So since we saw like we need to write a lot of Cypher queries, like manually we need to do it each and everything. So in graph AuraDB, there's like option where you can use the click and drag and drop options are there. So you can directly convert a column into a edge, name an entity into edge, and their relationship into a like a edges and everything. That will be easy to do it in a Neo4j AuraDB than graph desktop version. So Neo4j comes with like a handy Python like installer versions we have. So that will be much more beneficial for people who wants to use the Pythonic version of Cypher queries. So we'll be using we'll be installing like the Python versions, and then we'll be using the same set of Cypher queries within a Python tag and comments. So that's the brief like in development of like edges and notes creation. So let me know like if you have like any questions I can address, and also I will be attaching the same Cypher queries for you and Python queries for you and the entire graph as well. So you can try it online, and you can come back to me anytime. At the time we have like a set a community page where I'll be like available 24/7. So I'll be okay to send with personalized messages as well for me, and we can chat as well. Let me know if you have any questions.
Thanks, Roopesh.
That's our end of the session right now.
Thank you very much. That was very
Thank
informative.
you.
Thank you.
Thank
Have a
you.
nice weekend.
Thank you.
By the way, I solved my
Thank you.
visualization issue. It worked finally.
Yeah.
Yeah.
It's working?
Yeah, it is.
That's nice. That's nice.
Yeah. Thanks.
Welcome. Yeah.
Well, possibly I have one question.
Yeah, sure.
Do you have also typed data?
Sorry?
Do you have typed data? I mean, for example, when you put sex, no? You could force to choose only between male or female, or possibly male, female, and no gender. And this is different than choosing from a free text, no? That you have to type.
Yeah. So it's written in a way like it is possible for us to customize, but basically they are like a node properties. We can give like n number of properties, whichever we want, we can give it in different options also we can give. Yeah.
Okay, so in each property there is the option of typing the
Yep.
data.
Exactly. Yeah. We can give numeric data like textual data or anything. Yeah.
Okay.
So yes, we can make different colors for our nodes to like to highlight much more readable way. Yeah, it's possible.
Thank you.
Rupesh,
Yeah.
you know, I think I just want to play around now with the we're creating nodes, creating relationships. No, that was very useful. That script you had that created the relationships between all the people, Facebook and so on. Is that something you can upload to that portal?
Yes, definitely. I'm going to upload each and every materials which we have in our class. Yeah.
Fantastic. That would be great. Yeah. I'm I'm currently creating relationships between me and my wife that didn't exist ever.
Yeah, that's nice. Good.
Good stuff. Thanks very much. Very, very interesting. You know, I can see it's a very efficient way of a much more efficient way. We've been doing relationships in a non-native way in SQL databases for years, but they
Yeah.
are very expensive to execute. You know, this looks like a cleverer way of doing the same thing, particularly if all the data is built in. If all the data suits a native graph type environment, you know.
Exactly, yeah. So that's the fantastic way of like our graph data. So we can connect with our entire real world problems. Say, for example, yeah, we just like the husband, wife, we are connecting like it's connected like children's, grandfathers, grandmothers, anyone we can connect. Likewise, we can go on with like a banking data. We can go on with like our stock market data. We can go on, or like a company specific NLP data, or like any textual data. Anything we can connect with this. Yeah.
And tell me, the query language, is that a standard for all graph type query languages? So if, for example, like you have Neo4j, Neo4j, there might be something up on Amazon and Azure. Do they use a similar query structure, or is it totally different?
Basically, these cipher queries are inspired basing like using our SQL. So the cipher itself like similar for Amazon Elasticsearch. They also have the cipher something, but the syntax is like minute variation is there.
Okay, so but it's similar anyway.
Yeah,
If you
it's
get,
simple, yeah.
if you were to understand Neo4j and you try to move to another one,
Exactly, yeah.
yeah,
Yeah.
that would be okay. Yeah.
Definitely.
Cool. Yeah.
Yep.
I'm missing the call on my wife relationship.
Nice.
A bit there. Yeah, listen, thanks for that. I shall
Yeah, definitely. So next week we have our like an important session, lab session. So we're gonna do our hands-on session, like creating like a multiple, like big amount of Facebook graph. And later on with that graph, we're gonna use our recommendation system. Yeah.
okay.
Thank you.
Thank you very much.
Thank you very much.
I've now managed to marry my wife.
Nice.
Okay, listen, thanks very much for that. I've no more questions at the moment. I'll play around with that for a bit.
Definitely, sure.
I'll tell you as it if he's still there, he's gone.
Definitely.
Okay.
Thank you. Yeah.
Thanks very much.
Thank you.